video, I'm going to discuss scientific notation. I apologize, the lesson has had to change a couple of times since I've been quarantined, and so this presentation doesn't perfectly match the notes that I've provided to you. I'm going to try and help you fill those in as you move, as I move through here. So when we talk about scientific notation, we're looking at ways to represent really big numbers or really small numbers. In chemistry, sometimes we're talking about the number of atoms, and we've already seen Avogadro's number, that's 6.02 times 10 to the 23rd. That's a crazy big number if we write that out. Right? A really long number is called standard notation, or the number 5 is in standard notation. So scientific notation is an integer, which is any number between 1 and 10, and then a decimal point, and then a few places, times 10 to something. Okay, so in our class, our rule of thumb will always be number, decimal point, number, number. So we will always follow this format that I've laid out right here. Number, decimal point, number, number, times 10 to the something. Okay, we'll get into which way the direction, or which direction those exponents move things on the next slide. But what we're getting at here, what we're taking advantage of, is the fact that when we multiply by 10, we move the decimal one spot. 1 times 10 is 10, so the decimal moved. Let's do 2 times 10. 2 times 10 is 20, so the decimal moved from after the 2 to after the 0. 2 times 100 is 200. We move the decimal 2 spots. 2 times 1,000 is 2,000, so we move the decimal 3 spots. We do the same thing when we divide by 10. We're moving the decimal 1 spot to the left every time we divide by 10. So that's what we're taking advantage of here using scientific notation. I gave you a couple of examples of formats that don't exactly match our given format, but definitely are still in scientific notation. These still represent scientific notation. It's just not exactly the format that we're going to use in Pre-AP Chem 1. So, like I said, why do we use it? Because they're really, really big numbers or really, really small numbers. So that makes doing the math cumbersome. It's easy when you're writing 17 zeros to drop one and actually only have 16, or key in the wrong number of zeros on your calculator. So let's look at how we put big numbers into scientific notation. So notice on my example there on the left, I've got a big number, right? 1452098, and there's my decimal point. The things that are in black and gold are before the decimal. The things in red are after the decimal. So what I'm going to do is I'm going to put my decimal point so that I only have one digit to the left of my decimal point. Then what I'm going to do is count the number of spaces I had to move my decimal point. So my decimal point was right before the last 0. So 1, 2, 3, 4, 5, 6. So I moved my decimal place 6 spots to the left. So I have to use a positive 6 as my exponent. I got the 6 from the fact that I had to move it 6 places. I know that it's positive because if I multiply a number by a big number, I get a big number. If I multiply a big number by a tiny number, I get a tiny number. So again, all we're doing is moving the decimal by, this is a fancy way of multiplying by 10. It's not 10, it's 10 to the 6th. I don't know what that is off the top of my head, but it's a big version of 10. We're moving the decimal 6 spots to the right. So at this point, let me jump over to your notes. At this point, we should be right in here-ish. I've given you that standard form, and here are some numbers in expanded form or standard notation. And then here is where we are right now. So we should be able to move this decimal. Okay, so we would end up with 3.85, 3.86, because we're going to round, times 10 to the 1/2. 3.86 times 10 to the 3rd would be our scientific notation here. If that doesn't make sense, pause the video, think about it for a few seconds, work your way through it, and then resume the video. For small numbers, let me switch back to my notes page here. With small numbers, same kind of setup here. Black and gold is everything after the decimal this time. Red is everything before the decimal. So to get into scientific notation, I want to write my number so that there's only one number to the left of the decimal, and then count my times I had to move. So I'll start here, and I'll go all the way to that 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that tells me I have to move it 8 spaces. I have to move to get back to my standard form. I have to move to the left, so I use a negative exponent. Over here, we've got 8.00851. So my scientific notation will be 8.51 times 10 to the negative 1, 2, 3. 8.51 to the negative third. I gave you some to practice right here. I will post a key to those. I don't have it created yet, but I'll post a key to those practices, and I'll post a key to these practices as well, which is going the other way. So taking scientific notation and translating that into standard form. So again, if you've got a positive exponent, we're going to move 3 spots to the right. Here we've got a negative exponent, so we'll move that decimal 2 places to the left. So that's the basis of how you will use scientific notation, getting numbers into and out of scientific notation. We also need to be able to do math using scientific notation. So if we are adding 2 numbers, honestly, if I'm you, I'm screenshotting this screen, specifically this part, maybe not me. But these rules will help you do scientific notation without your calculator. So if we're adding, we rewrite the number so that the exponent matches, and we can add the coefficients. So if we have 10 to the third plus 10 to the fourth, we need to rewrite both of those so that they're in 10 to the third, and then we can just add the big numbers. Subtraction, we're going to do the same thing, but we're going to subtract the coefficients. When I say coefficients, I'm talking about the big numbers, right? So like 3.23 times 10 to the something, 3.23 is our coefficient. So if we can, in addition and subtraction, we need to make the exponents match and then do the math operation on the big numbers. Multiplication and division, we're going to do the operation on the coefficients and then do something different with the exponents. Okay, so here in multiplication, we add the exponents. In division, we subtract the exponents. And then obviously we're going to multiply and divide accordingly. So I'm sure that didn't make perfect sense. There are so many good YouTube videos that show examples of this. I'll link one of them to kind of show you the process of doing math with scientific notation. But I don't want to overwhelm you. So let's make this video focus on getting into and out of scientific notation. And then once you master this skill, I'll post that second video for this, doing the operations.